Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born. The first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.
Hey everyone, my name is Isabel. I have Mafalda here with me. Hey Mafalda, and we're going to be hosts for today. So this webinar is going to have the following agenda. We are going to open the meeting, then we're going to have our talk by João Ramos, followed by a short Q&A, and then we are going to have our networking session. So stay tuned until the end because we have surprises. So for the ones that do not know us, the DSPT is an informal community of data scientist enthusiasts, and we have the main purpose of sharing knowledge and experience. And in order to do that, we kind of have a do's and don'ts philosophy in which we do promote knowledge sharing, we organize open events, we try to break the barrier between the speaker and the audience, but we don't like any bullshitting or selling in any of our talks. But if you do have any idea or any project that you want to share with the community, please do and use our call for proposal template. Where you can find us? You can find us in Aveiro, Braga, Coimbra, Lisboa, and Porto, but you can also find us online in datascienceportugal.com or in any of our social media platforms such as Meetup, Facebook, Twitter, GitHub, LinkedIn, and Slack, obviously.
I want to thank to DevScope and OutSystems as sponsor for today's webinar, because without you guys, most of this wouldn't be possible. Next slide. And for the Q&A, please don't forget to post your questions on the YouTube chat. We'll make sure everything gets answered. Next slide. So regarding our speaker, we are going to have João Ramos with us. He has a master's in computer science and engineer at the University of Lisbon in Instituto Superior Técnico Faculty, and he is a co-founder of Starkdata. Hello, João.
Hi. Hello, everyone. Hello, Mafalda. Hello, Isabel.
Hello.
Sorry.
And the stage is yours.
Okay, thank you so much. So let me just switch over here. So today I'm going to talk about my computer vision journey, and so far because it's continuing continuously. So a brief introduction about me. As Isabel Mafalda said, my name is João Ramos. I live in Lisbon. I studied at Instituto Superior Técnico with a master in computer science and an AI specialization. And now I work at Starkdata as one of the co-founders. So my current journey. So I'm going to talk about 5 different projects that I worked on. So the first one about autonomous flying, then about hand gesture control, body language decoder, and AI gym body, and finally about space management. For each project, I will first do a quick approach of the steps I followed. Then I will show at least one example, one video about what I created. Then I'll talk about the challenges I faced and some possible solutions. And finally, some of the real-world examples of real-world use cases. How it started. So this whole journey started when I decided to buy this little drone, this DJI Tello. And why did I decide to buy it? Well, first of all, since high school, I always wanted to program a drone back like 8 or 9 years ago. And I finally thought it was time to buy one. And I decided to buy this drone because, first of all, it's a programmable drone. There's an official SDK provided by DJI. Then, second, it's affordable. It costs around 160 euros. And finally, it's ideal to fly indoor because it's very small, it's compact, and it even DJI even provides some propeller protectors, so it's super friendly to fly it indoor. Then I thought to myself, how can I make the smartest drone possible? And I had a few ideas. So autonomous flying it was one of them. Space awareness was another one. Building mapping was another idea I had. Obstacle avoidance, of course. Follow me while I was doing snowboard. Of course, I wanted to try something like that. Even try to fly by himself, to learn to fly by itself with reinforcement learning and using an Unity environment. Well, I didn't implement most of them. I started with autonomous flights. And I decided to start this project by implementing kind of a baseline, or what I thought it would be simple to do. So first of all, I decided to implement a simple algorithm that could follow me or follow my face. So I divided this project into two parts. The first one, I had to identify everyone that was in the camera. So I had to identify each face. Then I had to implement a tracking algorithm. So how does it before that? So about the object detection model. So to identify each person, I had to use an object detection model. So as you can see here, I decided to use a simple. I decided to start with a simple model. I used R's Cascade classifier from OpenCV, and I decided to use this model because, first of all, it's a light model. It runs without any fancy hardware. For example, using my MacBook, it doesn't have a GPU, so I could run it very, very easily. And second, because it was very simple to implement and use. And it's very important when you are creating your own projects, you want some quick wins. You don't want to spend 2 or 3 months implementing something and then to realize it doesn't work. So it's not so encouraging to keep continuing developing new projects. In terms of disadvantages, the performance of the model, it wasn't very accurate, as you'll see next. So for the tracking face algorithm, I implemented an algorithm that I think it's very simple to understand. So it's divided into several examples that I will show next. For example, the easiest and the first example of all, when the person is centered in the frame, so the drone doesn't need to do anything. It just needs to stay in the same place, because you are already, if you are following someone and if it's already centered, you don't need to do any commands. So second, imagine if the person is on the left side of the frame. So if the person is on the left side of the frame, then you need to tell your drone to rotate to the left so that the person goes to the center of the frame, to the scenario number 1. And vice versa, if the person is on the right side of the frame, you need to tell your drone to rotate to the right, to once again to go to the first scenario. And Then there are two other examples. Imagine if the person is very big in the frame, so it means that it's very close to the drone. So if the person is too close to the drone, it needs to go backward. And once again, vice versa. If the person is too far away or it's very small in the frame, the drone needs to go to move forward. So, and how you calculate if the person is big or small in terms of the frame. So basically, when you're using a bounding object detection, it creates a bounding box around the person, and you can calculate that area, and then you define a threshold. And for example, if the threshold, if the area of the bounding box is bigger than your threshold, it needs to do something. Otherwise, it needs to do the opposite. Here's an example. So it's me flying my drone autonomously, of course. So the tail turned on and moved up. As you can see, now it detects my face, and as I'm moving backwards, the drone moves forwards. Now I'm moving forward, and the drone follows me by moving backwards. Now I'm moving forward again. As you can see on the left corner, the image from the drone. Now I'm rotating to the left, and tail does exactly the same. It's a simple example, but it proves that it works, and it's something to work on and to keep working if I wanted to. So in terms of main challenges that I faced, like I said before, the only main I had two main challenges. Like I said before, the first one, it was the low performance of the model, since I was using that model already trained provided by OpenCV. It was very hard for the model to distinguish people if they were on the back side or from the side. And another challenge I faced was to tune PID. And PID is something that I will try to explain it a little bit in the next slides, but basically it's something related with robotics and movements. So in terms of solutions, the performance of the model, I mean, I think it's very easy to solve this problem. Basically, you need to implement one of the YOLO versions. It's either YOLO version 4 with Darknet or YOLO version 5 with PyTorch, or even you can convert both of the versions to TensorFlow and use it. And to tune PID, basically you need time, patience, and a bit of experience and experiment, of course. If you don't know what YOLO is, YOLO basically is a real-time object detection model. It's basically the state-of-the-art model, and it's the best you'll see. As you can see in this graph, so this is YOLO version 3, and these are other very competitive models. And as you can see here, YOLO takes half of the time to detect or to process images, and the accuracy basically the same. All right, now the hard part to explain. So what is PID? This is a real scenario. So imagine this flow. This is what I want the system to do. And this is the arrow. In this case, for example, the drone, what I want to do is, for example, to move forwards. And this is the arrow. Imagine if it can be translated to, for example, meters, to distance, to area, wherever. And with what you want to do and the arrow you have a controller, basically PID. And then this is what you want to accomplish. And this is a system that is continuously giving feedback, like you'll see. So, for example, in this scenario, you want the drone to move forward, to move up, to spin up, for example, 50 meters. And it starts here with an error of 50, and it gets here with an error of 0. And to accomplish this, you need to give acceleration to the drone. And you have two different ways to do this. Either you give it an higher acceleration to diminish the time, or basically, like it said here, so a faster acceleration, you have the risk of passing the points and will take less time, or you can take a slower approach with it, which is more stable, like, for example, in this case over here. In terms of real-world applications or examples, the first one it's about fast food delivery. It's a futuristic example, of course, but I'm sure it will be possible in the future. And two other examples that have been they have been used currently. For example, for agriculture, to inspect and control a variety of crops, and for example, for equipment inspection, more frequent, more accurate monitoring of large and dangerous equipments. So at this point, I could control my drone with my smartphone, for example, using the native DJ app. I could control my drone using my keyboard from my laptop using a simple API that I developed. And I found two other ways to control the drone. Either I could, for example, control it with my hand gestures using a model, or, for example, using voice once again to control the drone. And then I decided to start by implementing a hand gesture decoder to control it. As you can see in this very, very simple example, how does it work? So with the first example, with the keyboard, you give your instructions to the drone, then you click on your keys, they go through the API, and the API gives the commands to the drone. If you want to implement either an hand gesture decoder, and either if you want to implement a controller either with hand gesture or with voice, you need to go through a decoder. A decoder is basically, in this case, a machine learning model that translates either hand gestures or voice commands to programmable commands that can then be connected to the API and then to the drone. So moving to the next project number 2, about hand gesture control. Once again, I divided this project into 2 different parts. The first one, like I said before, is I had to use, in this case, to use a machine learning model to detect hands and figures in real time. And then with that information, I had to create a decoder, basically, in this case, a machine learning model, once again, to translate those points into gestures. So for the hand detection model, I used media pipe and hand model. In terms of advantages, MediaPipe has a really good documentation. It's very simple to implement. It works with almost any other hardware. It's very light. I will show a bit later, but they have models trained, for example, for Android, for iOS, for a variety of hardwares. In terms of disadvantages, I didn't find anyone, honestly. It's a very powerful model. It's very, very good. It gets its job done. I couldn't find anything bad about it. So about this model, like as you can see here, it detects 21 points, 21 points in each hand, and then with those points, I had to translate them into the machine learning model. I decided to create a custom neural network. In this case, a simple one. This neural network has 4 fully connected layers and one softmax layer for classification. Well, I decided not to go or not to implement a very hard neural network once again, because first of all, I always like to create a baseline or something that works rapidly, so that I can, for example, I can debug, I can have some quick wins or fast to don't lose the hype, honestly. So in terms of advantages, it's simple. It gets a job done. Actually, since it only has 21 points and it's simple for the model to understand what commands I'm saying. Yes. In terms of disadvantages, it's not I don't think it's a neural network ready for or reliable enough for production, honestly, if you want to go further with this type of solutions. As you can see here, I implemented a safe zone, so only gestures inside the safe zone will be detected as commands. It detects different gestures, like you can see. It detects fingers movements, for example, clockwise and counterclockwise. I'm going to show it again. So, for example, right now it's not authorized because it's not inside the safe zone. Now, as soon as I get my hand inside the safe zone, it moves. Okay, now they are authorized. You can see different commands being shown, finger movements. In terms of project review, I had to create my own data set, which is hard. The model was able to distinguish easily different hand gestures. I think that's a win. It was relatively easy to create a model for classification, and I didn't find any major complications, to be honest. Some real-world examples. Hand tracking for VR is one of them. It's to interact with VR without needing controls. Basically, you only need a webcam or a camera. A virtual desktop, once again, to control devices through your hand gestures. You can use it for example, for a virtual piano or to play any other instrument you want. And in my opinion, the most important one to sign language understanding, so that you can understand a sign language instantly, without even knowing how to say things in hand gesture and sign language. At this point, I realized, whoa, MediaPipe is really powerful. What else can I create with it? Now I'm going to show you some of other models that MediaPipe offers. Before I continue, MediaPipe is a library created by Google. It's a different company, but it's under the Google umbrella, and it's very powerful. Like you can see here, they have a model for face mesh. It detects hundreds of points in a face. The model I've shown previously about hand tracking. They also have a pose detection model and tracking, for example. They have a model for object detection. For example, in the first example about the drone, you could use also this object detection model to detect faces and people. They also have a 3D object detection so that you can detect objects in 3D, and it's missing an H over here. Hair segmentation, for example, if you want to use or to create a filter for example, for Facebook, for Instagram, for TikTok, you can basically segment your hair and then apply different colors and filters. So next projects. I decided to explore a little bit more about media pipe. So I googled a little bit what I could do with this kind of models, and I decided to do these two next projects. The first one, body language decoder, for example, to understand poses, to understand reactions, and basically to understand body language. And then a very simple one, I decided to create, like I call it here, an AI gym body. So it's a pure algorithm model, but it detects body parts and joints and then calculates their angles. Let me start with the easy one, the AI gym body. So once again, this project is divided into two major parts. In the first part, once again, I had to detect the body parts, and I had to do it also in real time. And then with that information, I had to create an algorithm that could calculate the angles in the body parts. This model is a little bit more challenging, or it has more points. Instead of 21, now we have 33 points. And we'll see next, but in terms of disadvantages, this model has a low accuracy when different parts in a body are overlapping, or for example, if a person is using too much clothes on, or if it's using baggy clothes, it's difficult for a model to detect those parts. For example, the joints, the knees, it's difficult. In this first example, so this is the first example without any overlays. It's a simple example and an accurate example. It's a personal example. It's me training. So as you can see, I'm going to show again the joints are detected properly and there are no major errors. So it looks okay. It looks easy, and it's doing its job. So then of course, I tried different examples. In this case, it's an high resolution example in slow motion. This example it is detecting at 30 FPS. It's filmed from the front in this case, and you can start seeing some errors as I'm going to show again. For example, in the knee and in the elbow, you can start detecting a few errors to occur, like over here and here. And in the third example, it's a completely mess. So in this example, there are a lot of muscle overlap, and it's a messy example, like I said. Also, once again, a personal example. It's filmed with a similar angle from the first example. It's not a study shot for the first time. The person that is filming is moving a little bit. There are a ton of overlay in the muscles, and sometimes some of the important body parts may not show properly. For example, my knee may not show the knee or properly. Like I'm going to show it again. So in this year, the knee is not even showing. So it's very difficult or impossible to calculate. And yes, I mean, it's a messy example. So in terms of main problems and solutions, I think there's just one problem, to be honest, and it's the accuracy of the model. It's very, very low when muscles overlap. And if the joints aren't properly detected, it's impossible to calculate the angle, and this use case is completely useless. In terms of solutions, to be honest, I don't think there's a solution. I think it's borderline impossible, or for me, to do by myself to compete with a model as good and accurate as Google is doing, or MediaPipe in this case is doing. And although it doesn't work, or the accuracy is not enough in my use case, it doesn't mean that in other, for example, use cases, the model is useless. So different use cases need different types of accuracy, basically. In terms of opportunities, I think there are a lot. For example, in physiotherapy, to help patients recovery, in terms of apps and programs to, for example, to training, like I was trying to do before I realized the model was useless in my use case. But for example, to create a software or an app that could help you train and know if you are doing your exercises correctly or not. It can be helpful to correct your posture and for posture monitoring and observation. And like I'm going to show next, for example, for body language and body language detection. So the hardest one so far, body language decoder. And it's the hardest one, mainly because instead of using one model, I'm using 3 models at the same time. So I'm using a body detection model. I'm also using a face mesh detection model, and lastly, a hands detection model. So I'm combining all the points that these models provide into one single data set to then try to classify what the person is feeling or is saying or transmitting, etc. So this project is divided in 3 parts. So the first part is the models, the detection models. Then I had to create once again my data set, but in this case was so much more complicated. And then the custom model to classify the body language. Like I said, for detection models, 3 models: face mesh and tracking, and pose detection and tracking. Well, to build a data set, and it's not showing properly. I don't know. Okay, we'll see it later. So to build a data set, I use a notebook because I think it's easier to do these kind of things with a notebook. Okay, it's showing now. I use OpenCV to stream from the webcam to my computer, and then while it was recording, it runs basically all the 3 models in real time, and it takes all those points and puts plus a class and puts all of that information in a CSV and saves, and does it for every frame, like I'm going to show again. So as you can see in this example, Joanna is keeping the same posture, and as you can see, it's running the background and it's creating the data set. I have another example. So as you can see here, Joanna moves around, camera change, she tries to change her position, but keeps the same posture, like in this case with the finger up, to try to create some diversification. And ways to improve this dataset building. So three easy ways to improve. Okay, not easy ways to improve, but easy ways to understand how to improve it. So, for example, she is always sitting down. So, for example, by standing up with more points, and maybe even try to use different people. For example, although it's the same posture, different people have slightly different ways to transmit it. And then, for example, to move more around the camera. So, third example, while building the data set, it's very difficult to create a data set with, for example, in this case, we are creating our own data sets, and it's borderline impossible to create thousands or millions of records with a low percentage of outliers. In terms of classification model, well, I'm going to be honest, I was a little bit lazy here, so I didn't implement a neural network. So I tried three different models: rich classifier, random forest, and gradient boosting. The three of them had similar performance. So I end up using gradient boosting. How to improve accuracy? Easy way to understand with a convolutional neural network, a CNN, or any other more robust neural network. In terms of advantages, it's a simple baseline, to be honest. I keep saying simple, it's a simple baseline or a simple model, but I like to start with simple models and then go from there up. In terms of disadvantages, it was very hard to distinguish different postures, for example, due to a high number of inputs, but we'll see more examples. So in this first example, in terms of classes, I had normal, happy, hello, shocked, be quiet, in this case with the finger up, flex, like you can see now, and peace. In terms of results, it was able to predict accurately in a control environment. What I mean by control environment is by, for example, being stand down and being relatively mimicking similar positions we did in the training. It was difficult to distinguish postures similar postures. For example, normal with happy. So normal, it was by being like this, and happy was something similar but smiling. So it was very hard for the model, or this simple model, to understand. And it was easy to identify classes that are very different from the others. For example, flexing, it's with your arm standing up, it was very easy, and even hello was kind of easy to classify. Now the second example. So this example, once again, the same classes, but the results are completely the opposite. And like you can see here, so it's basically predicting everything randomly. And in this case, for example, it's not due to the model itself, but due to the poor quality of the data. So this is actually the first example that I trained and used, and I didn't take in consideration the quality of the data. So I realized that I had a lot of outliers, almost as many outliers as good and quality data, and so it was just predicting randomly. So then I had to build another data set from scratch, and then I have the results I shown previously. Main obstacles, a lot of them, to be honest. So the first one, like I said, the data set was very small. it had low quality with few examples and low diversification. Like I said, I talked about all of these during this project, this example. The model itself, I use a baseline and simple model, so it would be always very hard to distinguish similar postures. And I think the third one is the most important one, to be honest, the outputs. So the face landmarks, that model produces 468 different points. Then I had to sum the hand landmarks and the pose landmarks. And then multiplying all of that for X, Y, and Z, I had a combination of 1,500 points, different points, and there are just too many points for a simple model, basically. And last, the complexity of the problem. It was overall a problem with too many difficulties. In terms of possible solutions, data sets, I think time equals quality, like I wrote here, and it's true. If you spend more time developing or creating a good data set, a bigger data set will be also very useful, of course. And the third one, still in the data set, to be more careful with the outliers and more diversification. In terms of the models, solutions, a more robust neural network, or even a neural network similar to the one I created to the hand gestures, for example. In terms of inputs, for example, by trying to use less points from the face mesh, instead of, for example, for 100 points, you maybe only need 50 of them or something like that. And in terms of the complexity of the problem, maybe divide and conquer. And what I want to say here is start with smaller problems and go from there on, basically. Last project I'm going to talk about today, about space management. And this is the project I love the most, to be honest, and what I've been currently working on. So in this project, the goal is to control and supervise physical spaces. Here there are a ton of challenges, and like I'm going to show two different examples. And the first one is people counting. It's an easy challenge. And the goal here is to know exactly how many people are inside the space, how many people entered, how many people exited. Very simple to do, nothing complicated. So in this case, it's also used, once again, a model to detect people, and then an algorithm for the tracking part. So the tracking part is a Euclidean distance that calculates the distance from, for example, the frame to the previous frame, and the IDs, and associates the person that is close in the next frame to that person. And then, for example, another example about customer journey. And with customer journey, usually you want to know exactly where people went, where they stopped, for example, what stores they went from, and even, for example, it maps to know where the spots that people stop by the most. And for example, in these use cases now, I don't use baseline models anymore. For example, in this case, I'm using YOLO V4 because, in my opinion, it's totally a personal opinion, but it's my personal and favorite YOLO version. And in terms of real use applications, I only wrote 4 here, but there are a ton of them. So like I said before, people counting is one of them, to know exactly how many people are in and out in a current occupation, and the current occupation. For example, people segmentation. I don't know. I'm pretty sure this one is not legal with RGPD, but to know, for example, in a space, how many people are with each gender, for example, to know the age of the people that, or not the age exactly, but to know if this person is young or old, to know the customer insights, for example, like I said before, customer journey, customer density, and even, for example, this last one, cashierless checkout, for example, like Amazon is doing, and since a Portuguese company startup is also doing. Well, and that's it. I hope you all liked it. And Isabel Mafalda, not sure if what's next, maybe Q&A, right?
Yeah, we do have a couple of questions already in our YouTube channel, so let's get started.
Mm-hmm.
So the first one is, how was the communication between DJI and the backend done? Can you explain a little bit more about the pipeline?
How was the communication between DJI and the backend done? I don't have an example over here, but okay. Let me go to here. Oops, not this slide. The communication, like, for example, the communication, I had to use the processing, it's not doing in the drone itself. So the drone is connected through Wi-Fi. So the DJI Tele creates an Wi-Fi. Then I had to connect my MacBook to that Wi-Fi. And then basically all the backend and processing is done in my computer. So I receive the stream of the video in my computer. Then I run the model in real time in my computer as well. And then basically based on those frames, like I shown here, I give those commands to DJI. Yeah, and that's it. I'm not sure if JP, if that's what you're asking or not.
If not, please do
Yeah.
add more information.
Okay, my turn.
Okay.
Do you intend on improving the gym body project?
Well, I developed. I'm not going to say a lot of time, but some quite decent hours on that project, and I really wanted to keep developing this project because I train basically every day. So it was a project I really wanted to continue, but unfortunately, I don't think it's possible at the moment. So I could develop or create an app to continue with, but with these kind of examples, I don't think it would be very, very popular, to be honest. So at this time, no, I don't think I'm going to continue improving these projects.
Okay, thank you. How does media pipe work? Underlying mechanisms.
Yeah, I don't know if I understand that question. The underlying, so it's not an API. It's like any other model that you download. For example, you download the pre-trained the weights of the pre-trained model, and you implement it like any other model. So it's not an API, and the source code it's all in my computer and in my site. I'm not sure if that's the question, but Peter, if it's not, please say something about it.
Yes, if you have any doubt, Peter, please talk with João in LinkedIn or after our network session. Your turn, Isabel.
And we have people curious about to know if the code is available.
Yeah, currently the code is not available. Maybe I will provide some of the code, but some of the things it took me some time to implement them. Most of them at least 2, 3, 4 weeks to implement. So, but yeah, probably some of them I will provide because I'm not using them for any other application at the moment. But yeah, possibly. But if you want to continue any of these projects, so feel free to reach me, and I will share the code with you without any problem.
Next question. Regarding the tracking from the last project, do you have any problems when two persons walk side by side in the same direction and their trajectory diverge?
Yeah, that's an easy answer. So basically what I do is, so let me just go to that slide or a similar slide. So the object detection model detects everyone. So what I do is basically I calculate the bounding box for each of the person for everyone, and I calculate so the higher the area is, the close the person is. So what I do is I only track the person that is the closest to the drone. That's the way I decide to implement this. So if it detects multiple people, so the drone will only find the closest one.
Okay, that's really interesting. And another question that we have in YouTube chat is, do you plan to make any of these projects a real-world product?
Yeah, the part of the space management problem, yes, I'm currently working on that, and that's why I'm not that's why I'm not showing a lot of information about it, because it's something that I'm really doing at the moment, and that's something that I really enjoy doing, and I want to continue developing and create some real world applications for that.
We do have a follow-up comment on the last question regarding the tracking.
Okay.
David mentioned that he was talking about the last project.
Okay. Walk side by side in the same direction. Won't their trajectories merge? Sometimes, yes. And I'm using YOLO v4, so it's the state-of-the-art model. So about the object detection, about it, there is nothing that I can do. About the tracking mechanism, for example, what you are saying. So imagine if I'm running with even with 30 FPS, so the distance will be between each frame will be significant, so it doesn't occur that much. People colliding in the same direction and creating basically imagine this is person number 1 and this is person number 2, and then they collide, and instead of this person number 2 going this way, it tracks the other person. But no, it's an example that doesn't occur that much.
Thank you. The next question is, what are some computer vision problems you think that a startup in Portugal can have success in?
What are some projects, applications that the startup can you repeat again, Mafalda, please? I'm sorry. Okay, I can see here. What are
yes,
some
you
computer
can
vision?
see it, but the question is, what are some computer vision problems you think that a startup in Portugal can have success in?
I think there are a lot of different things. For example, there are a lot more applications with computer vision that I didn't explore yet, because, like I said, this is my journey. So I kept changing and experimenting different things until I found what I really like to do in this space, which is space management. And this is, for example, something that I want to continue developing. But I think there are a ton of different things. For example, different things. Even for example, with autonomous flying, for example, there are a lot of different things.
Yeah,
It depends of the passion of the person. I think that's the most honest answer.
I think the hardest part is having the idea. Once you have the idea,
I think it's actually the opposite way around. So I think it's, at least for me, it's very easy to have ideas. It's very difficult to accomplish them and to build them. But yeah, different people have
yeah, it's different
opinions.
perspectives.
Yeah.
And the final one is, what is going to be the next project?
Yeah. So my next project is still about space management. I have a ton of ideas. For example, for example, people counting is the easiest one. People counting is the easiest one. Customer journey is something very difficult. Still all related with space management. Customer journey is a little bit more difficult because, for example, if you are moving from camera to camera, how do you track the same person in two different cameras? It's very challenging to do, and that's another thing I want to keep exploring. For example, even another thing that I'm doing at the moment, for example, instead of using YOLO, for example, or computer vision, these kind of models need a lot of computer power, computation power, for example, GPUs and a lot of hardware. But if you want to do all those calculations in a camera, for example, by using a Raspberry Pi and a smaller camera, how do you implement those kind of models with such a low computational power? So that's one of other challenges that I'm facing at the moment, and that's also something that I'm developing at the moment. For example, in a highway, to know exactly how many people pass by a highway, there are a ton of different things, and it depends of the passion of the person. But yeah, all my next projects in computer vision are related to space management.
It's really nice. So we don't have any more questions on our YouTube chat. So I think we are going to close this session for now. But I want to thank you so much. Oh,
I think
yeah, we get another one. Go ahead,
Okay.
Mafalda.
okay. The last question is how I can show. Yeah, sorry. How did you create the Manchester dataset to train the neural network?
That dataset was very similar to this one, but instead of tracking the person itself, I only had to track one hand, so it was quite easier to be honest. You're not seeing my screen. I'm sorry.
No,
Okay.
It's showing now.
Okay. Yeah. So the process was basically the same. So, but instead of doing for one person, I had to do with only one hand. So it was quite easier, but different, but the same.
Okay, thank you. I think we don't have more questions. I think we can close.
Yeah, I want to thank you, João, for this amazing presentation. I think it was really insightful for everyone. And in the discussion, we were able to show that there are different perspectives. For some people, it's hard to get ideas. For some people, it's just hard to execute them and execute all of them.
Yeah, very true.
But do not forget to stay with us because we're going to have the networking session.
Okay, thank you so much.
Thank you.
See you soon.
So thank you guys for being here for this journey, for this presentation. Do not forget that if you have any idea, any possible project, or even if you simply want to share everything that you have been doing until now, Use our call for proposals. We are always looking forward to have you guys here with us presenting things. And thank you for everyone has been on the other side on YouTube. So do not forget, we are going to have a networking session and you can join us. Thank you guys. Bye.
Bye, guys.
Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born. The first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.